This is illustration 31 trigonometry. Now fx function is cos square cos x plus sine square sin x, and we have to find maximum value of fx. Now to find maximum value of fx, we'll take this into two parts. First of all, we'll consider cos x whole square, and then sin x whole square. Now cos x whole square we treat it like this. First of all, x goes into cos, so output is cos x, and then cos x goes again into cos, output is cos x, and cos x goes into square function. We get the output is, this is cos x whole square. So basically we are finding the range of this function first, the values, the minimum value and the maximum value this cos x whole square can take. Now you know cos x, for all values of x, for x belongs to R, cos x lies between -1 and 1. You can see from the graph of cos, it lies between -1 and 1. Now this -1 to 1 we feed to cos x again, and now we need to look at the graph of this. We feed input -1 to 1 to the cos function. So you can see from this graph, if x lies between -1 and 1, then corresponding values of y lies between cos 1 to 1. This is 1, cos 1 to 1. For these values of x, y varies on this part of the graph, or exactly on y-axis the takes values from cos 1 to 1. And when we replace this cos 1 to 1 into square function, we get cos square 1 to 1. So you can see this function ranges from cos square 1 to 1. Similarly, sin x whole square, first of all x goes to sine function, output is from -1 to 1, and when -1 to 1 goes to sin x, we need to look at the graph of this. -1 to 1 is the input to the sine graph. Correspondingly, y varies on this part of the graph, and the values which y can take are from minus sine 1 to sine 1. And when we replace minus sine 1 to sine 1 to minus sine 1 to sine 1 to the square function, you know square function is like this: minus sine 1 minus sine 1 to sine 1. Square function, you can see, varies from 0 to sine square 1. Now this part varies from cos square 1 to 1, and this varies from 0 to sine square 1. Now the maximum value the sum can take is 1 plus sine square 1, when this becomes maximum and when this becomes maximum. But we need to check whether the maximum of the two functions can exist for the same value of x or not. And in this question it is happening. If you see, this maximum value of sine square 1 exists when we replace x equals to pi by 2. We replace x equal to pi by 2, this will throw 1 out, and this will throw sine 1 out, and square will be sine square 1. So this function will take its peak value for x equal to pi by 2. Now for x equal to pi by 2 only, for x equal to pi by 2 also, this function takes its maximum value. When we replace pi by 2, cos pi by 2 is 0, and cos 0 is 1, and 1 square is 1. So both the functions possess maximum value for the same value of x. So that's why the maximum value of the whole function fx is 1 plus sine square 1. See, this is not the exact method to find the maximum values of a function. Not in every question this will happen, that when this function, the value of x for which this function possesses maximum value, for the same value of x this function possesses maximum value, is not going to happen in every question. So the correct method, the right method to solve these kind of questions is derivative calculus, differential calculus. We differentiate this function, and from the derivative we analyze the maximum value when the sum of these two functions can be maximum. The maximum value of fx means when the sum of these two is maximum, the value of x for which sum of these two is maximum. We don't analyze independently, we analyze this as a one function, but that will come later when we study calculus.